Hi, my name is Vijay and we are here to talk about thread pools. But before starting with thread pools, let's see how we work with threads traditionally. We create tasks by implementing the runnable and callable interfaces, and we create worker threads to execute such tasks by extending the thread class. Let's see the same thing via a piece of code. We are implementing the runnable interface and defining our work, that is my runnable task. And in the main method, we are creating an object of my runnable task, and to execute this task in a separate thread, we are creating a new thread and then calling t1.start method. Pretty straightforward. Let's try to see another example. Here we are creating two runnable tasks, my first runnable task and my second runnable task. And what are we doing in the main method? We are creating an object of my first runnable task. To execute that in a separate thread, we are creating a separate thread by calling the new thread constructor and passing a my first runnable task object and then calling t1.start. And after starting the first thread, let's assume some other code is running in the main method. And meanwhile, t1 thread has also completed its given task. Now we want to execute a second runnable task. But to execute the same in a separate thread, we are forced to create another thread. And this is the problem. So what is the issue? We are starting new threads for every task which we want to execute concurrently. That is, threads are not being reused. And as we know, with starting a new thread, there is an associated performance overhead. So can we do better? Of course, yes. And the approach is by using thread pools. So what are thread pools? A thread pool is a collection of pre-initialized threads. So we do not have to start new threads for every new task. But before going into details of thread pool, let us see the relationship between task, threads and thread pool. A task is nothing but the work that needs to be done, and that is defined in Java by implementing the runnable or callable interfaces. And what are threads? Threads are nothing but the workers that will execute the task, and workers are created in Java by extending the thread class. So what is thread pool? A thread pool is a set of workers or threads waiting in standby mode for tasks to be submitted to them. If we consider this as a thread pool, then we have three threads waiting in standby mode to accept the task. To understand how thread pool works, let's see what makes up a thread pool. It has a parameter of core pool size, and it specifies the number of threads you want to start the thread pool with. And then you have a maximum pool size. It determines when the existing or core threads are busy, till what limit can we keep on creating new threads. And then we have a third parameter, that is work queue or work queue size, and this would determine how the tasks that cannot be handled right away should be stored. And why they cannot be handled right away is because all the existing threads are still busy. And what is the fourth important parameter is keep alive time, that is after how much time the thread with no work should be shut down. Now to understand how these four parameters impact the behaviors of thread pool, let's take few scenarios. Scenario number 1. We have set the core pool size to 5, our maximum pool size to 20, our work queue size to 50. What does that imply? It implies when the thread pool is first created, it has 5 threads thanks to the parameter of core pool size. And when the first 5 tasks are submitted, we have 5 threads ready to execute them. And when the 6th task is submitted, there might be a scenario that 2 threads are already free. So in this case, the 6th task would be started immediately by any of the free thread. So in this given particular scenario, the parameters of maximum pool size or the work queue size does not even come into picture. Now to understand the impact of work queue size and maximum pool size parameter, let's take another scenario. Again, we have set the core pool size to 5, maximum pool size to 20 and work queue size to 50. And as we said earlier, when the thread pool is first created, it has 5 threads. And when the first 5 tasks are submitted, we have 5 threads ready to execute them. No problem. But what happens when the 6th task is submitted and consider all 5 threads are still busy? Kindly pause the video here and take a guess. The task would be pushed to the work queue where it will wait for any thread to become free. And this is where our work queue parameter comes into picture. So all such new tasks would be pushed to work queue until there is space available in the work queue. But what would happen when the work queue is also full? That is 50 tasks are present in the queue. So again, kindly pause the video here and take a guess. New threads are created. That is, maximum pool size parameter comes into picture. So new threads are created in thread pool till the limit set by maximum pool size is reached. And what about the fourth parameter of keep alive time? Let's understand that. Let's say again we have set the core pool size to 5, our maximum pool size to 20 and work queue size to 50. And our keep alive time is set to 2 minutes. Now what does it imply? It implies that excess threads would be terminated if they have been idle for more than keep alive time. And another important point to note about keep alive time is it applies to threads created over and above the ones specified by core pool size. That is, in our example, only the 6 to 20th threads would be considered as excess threads. These 2 points collectively also gives us one more important point to note, which is thread pool would always be having the number of threads greater than or equal to the core pool size. That's it. This is all for the 4 most important parameters impacting the behaviors of thread pool. Java provides us a lot of pre-configured thread pools. So let's try to understand some of them. We would be discussing fixed thread pool, single thread executor and cached thread executor. And since they all are pre-configured, let's look into the configurations. What is fixed thread pool and how does it work? Its core pool size is set by the constructor, and interestingly, its maximum pool size is also equal to core pool size. So kindly pause the video here and think about this implication. What does it imply? It implies that the number of threads are fixed. Now what does that imply? When the number of threads are fixed, we need a queue which is long enough to store all incoming tasks until the limited number of threads become free. So what do we have in such a case? Java has given us a linked blocking queue which is theoretically infinite. So let's try to understand fixed thread pool via a piece of code. We are having 3 runnable tasks. My first runnable, my second runnable task and my third runnable task. And in the main method, we are creating a thread pool by setting a parameter of 2, which means we are creating a pool of 2 threads. So when 3 tasks are submitted, 2 of them would be picked up by the first and the second thread respectively. But for the third runnable task to execute, it would have to wait in the work queue, and when one of the thread gets free, it will pick the third runnable task from the work queue. Simple. Let's try to understand single thread executor. Its core pool size is set to 1, and interestingly, its maximum pool size is also set to 1. So we are talking about a thread pool with just a single thread. And the number of threads are fixed, that is interestingly just 1. So what does it imply? It implies that again we need a queue long enough to store all the incoming tasks until the limited number of thread, which is just 1, becomes free. So again it uses a link blocking queue. As for the piece of code, let's try to understand. All we are doing is we are changing the fixed thread pool to single thread executor. Now what does it imply? It implies after the first runnable task is completed by the single thread of single thread executor pool, it would pick up and execute second runnable task. And when second runnable task is completed, the same thread would be used to execute my third runnable task. That's it. This is all for single thread executor. And what about cached thread pool? The most interesting one. Its core pool size is set to 0. And we also have the work queue size set to 0. Internally, we have a synchronous queue, and we would be creating a separate video with the details of synchronous queue. But for the time being, let's assume it's a queue of size 0. So in cached thread pool, we have a core pool size of 0 and a work queue size of 0. So kindly pause the video here and think about how cached thread pool might work. And also think about its maximum pool size, that is the maximum number of threads that cached thread pool can have. First of all, cached thread pool is a thread pool that creates new threads as needed, and it will reuse previously constructed threads when they are available. And also, if no existing threads are available, a new thread will be created and added to the pool. So if we summarize the entire points, what could be the value of maximum pool size? Theoretically, it is infinite. So let's try to understand the cache thread pool via a simple piece of code. Here we are having 3 runnable tasks. We have my first runnable, my second runnable and my third runnable. And in this main method, we are creating a thread pool by using new cache thread pool. And it might happen that for first and the second, we are having 2 threads created. And after submitting the third runnable task, one of the thread got free and it was used to execute the third runnable task. And it might also happen that 3 threads in total were created for executing the first, the second and the third task respectively. So this is how cache thread pool works. And this is for the pre-configured thread pools in Java. But what happens if I want to give my own configurations while creating a thread pool? Does Java give any option? Yes. It gives us a class called thread pool executor. It has a constructor which takes into account core pool size, maximum pool size, the keep alive time and the blocking queue. So let's try to understand thread pool executor via piece of code. If you want to create a thread pool of core pool size 5, maximum pool size 20, work queue size of 50 and keep alive time of just 2 minutes, all we have to do is use this constructor of thread pool executor and pass the necessary parameters of core pool size, maximum pool size, 2 minutes and the size of 50 for the array blocking queue. And we all know how this thread pool will work. So what have we learned? We have learned that Java provides us fixed thread pool, single thread pool which uses a queue type of link blocking queue. And since the threads are limited, we are using a linked list for storing the task. Java also provides a cache thread pool, and since it is using a synchronous queue which is a queue of size 0, which means the queue is virtually absent, there is no limit on the number of threads which can be created. And if we are interested in creating a custom thread pool, we can do so by creating a thread pool using a thread pool executor constructor. That's it. So if you have liked the video, kindly comment, share and subscribe. Thank you.